Okay, number one, what is a valence electron? It's an electron in the outside energy level. Okay, let's try number two. How many energy levels do the atoms of each of the following elements have? Well, let's just take a look at this. Here's lithium. As I look over here, lithium has 2. And I look at silicon. Here's silicon. It has 3. I just looked at the side here. It has 3. And then I find gold, which is Au, and I come over here and I see it has 6 energy levels. And then I see francium. Francium is over here. It has 7 energy levels. And then calcium, which is right here, has 4 energy levels. And promethium, where are you, promethium? Promethium, promethium, wherefore art thou, promethium? Seriously? Eric? Yeah, there's promethium. There's element 61. Aha. And so where does this belong? When we follow it back, and oh, there it is. It's got 6 energy levels. That was embarrassing. And then uranium, which is here. I follow this one back, and it's got 7 energy levels. And then helium, element number 2, is here, and it's got 1 energy level. Alright, now let's try number 3. How many valence electrons do each of the following have? We're going to look at the same element. No, we're not looking at the same elements, but how many valence electrons do they have? Alright, we'll start with calcium. Calcium has 2. The column numbers tell me 1, 2, 3, 4, 5, 6, 7, and 8. So calcium has 2. Then we're going to go over here to lead. Here's lead. Lead has 4 valence electrons. We're coming over here and find bromine. Whereas bromine's here, and it's got 7 valence electrons. And then we have phosphorus, which is right here, and it has 5 valence electrons. See, this isn't so bad. And then we've got potassium here, which has, there it is, 1 valence electron. And, better be careful here, we got helium. Now, you might be tempted to say helium has 8, but you'd be wrong. Helium is one we don't know where to put. It only has 2 electrons. See that? It's got 2 protons, it has 2 electrons. It only has 1 energy level, so they're on the outside. So it has 2 valence electrons. Then we have oxygen over here. Oxygen has 6 valence electrons. And finally over here we have aluminium, and it has 3 valence electrons. Alright, let's see. Which element has atoms with 7 valence electrons? That means it's this column in the 4th energy level. 4th energy level, that would be bromine. It has 2 valence electrons. That means it's one of these. In the 7th energy level, well, that would be radium. That's an R, by the way. Has 4 valence electrons in the 3rd energy level. That would be silicon. Well, let's just roll this up a little bit here. Alright, let's keep going. How about 1 valence electrons? What's with that? Okay, so you get when you cut and paste. 1 valence electron in the 6th energy level, that would be Cs. 5 valence electrons in the 4th energy level, that would be arsenic. And then finally we have 8 valence electrons in the 5th energy level, would be xenon. And we'll just keep the fun rolling here, people. What is ionization energy? Well, ionization energy is the energy needed to remove 1 electron from an atom. Let's try number 6. Which of the following pairs would be hardest to remove an electron from? Now, the thing to remember here is that as you go up the periodic table, it gets more and more difficult to remove an electron from an atom because there's fewer energy levels moving the electrons closer to the nucleus, And as you move to the right on the periodic table, there are more protons in the nucleus, making the pull on the electron harder. So the closer you get to helium, the harder it is to take electrons, and the closer you get to francium, the easier it is to take electrons. So as you go up, it gets harder. As you go down, it gets easier. As you go to the right, it gets harder to take electrons because there's more protons. And as you go to the left, it's easier because there are fewer protons. So let's just try this. Lithium or potassium. Here's lithium, here's potassium. Because lithium has fewer energy levels and the electrons are closer to the nucleus, the answer is going to be, in this case, is going to be lithium. And now we're going to try magnesium or chlorine. Here's magnesium, here's chlorine. Chlorine has 17 protons in its nucleus as opposed to 12. It's closer to here, and that means that chlorine is harder to remove an electron from. Our next choice is between oxygen and cesium. Oxygen is definitely closer to helium, so it's a smaller atom with a stronger pull on its electrons, so the answer here is oxygen. And then our next choices are between SN, which is 10, and tellurium, which I have no clue where is tellurium. This is terrible. Do you see tellurium anywhere? Seriously? Oh, there it is. It's right here. Okay. Between tin and tellurium. Well, tellurium has more protons, so it's going to be harder to take electrons from. That was so embarrassing. Now between neon and radon, because neon is a smaller atom, the electrons are closer to the nucleus, making neon harder to steal electrons from. And finally, our choices between sulfur and potassium. Sulfur is closer to here, meaning that it is harder to take its electrons. Okay, now the next question we have is, why does ionization increase as you move from left to right across the periodic table? You know, I don't want to write the answer, I'm just going to tell you. The reason it increases as it goes this way is because there are more and more and more protons in the nucleus, making the pull stronger and making the atoms smaller, bringing the electrons closer to the nucleus. The simple answer is more protons means a greater pull on the electrons. And our next question is, why does ionization energy decrease as you go down the periodic table? Well, as you move down the periodic table, the electrons are getting further from the nucleus because there's more and more energy levels, 1, 2, 3, 4, 5, 6, 7. So because there are more energy levels and the electrons are therefore further from the nucleus, the pull is weaker, making the ionization energy decrease. And then number 9, in each of the following pairs, tell which atom will have the largest radius. In other words, which is the bigger atom. So our choice is lithium or potassium. Lithium has 2 energy levels, potassium has 4, so the answer is potassium. Magnesium or chlorine. Well, because magnesium only has 12 electrons, it won't be pulled in as tightly. Since chlorine has 17, it will be a smaller atom, and so that means that magnesium would have a larger radius. Oxygen or cesium. Well, oxygen only has 2 energy levels, and it is on this side of the periodic table, which makes it kind of small. Cesium has a whopping 6, and it doesn't have very many protons for that many energy levels, so the answer here is cesium. And the easiest way to remember is the closer you get to here, the bigger they are, and the closer you get to here, the smaller they are. And finally, sulfur or potassium. Here's sulfur, and here's potassium. Sulfur is here near the smallest atom, so sulfur is going to have a fairly small radius. Potassium is more over here where the larger ones are, so the answer in this case is going to be K, potassium. Okay, I don't feel like writing anymore, so here you go. Why do atoms get bigger as you go down the periodic table? You know what, let's make this a little bit larger here. Okay. As you go down the periodic table, you are adding energy levels, and that makes the atoms bigger. Simple enough. Let's try the next one. Why do atoms get smaller as you go from left to right? Because the pull of the nucleus gets stronger because there's more protons, and that pulls the atom in closer. Let's try these next ones here. Alright, identify each of the following as an alkali metal, alkaline earth metal, halogen or noble gas. You know, guys, I don't think we did alkaline earth, but just so you know, that's column 2. I apologize. So let's just try this. A colorful gas that burns the eyes and throat. That would be one of these rascals here. That is a halogen. Halogen. And then a valence configuration of S2. Well, these guys here have an S2 configuration. These ones here are the alkaline earth metals. Colorless gas that won't corrode metal or sting your eyes. That looks like it'd be these over here, the noble gases. Noble gases. Let's see what we got here. I'm going to move this down. Number 15, an element with an unpaired s electron. Well, that'd be these guys here. They have unpaired s electrons, and that makes those alkali metals. And then has a S2P5. Well, that's 2 plus 5, that's 7. That's column 7. 7 valence electrons. And those ones there, fluorine through iodine, those are known as halogens. Okay. Now, let's see. I'm going to try moving this and see what happens. Oh, they move with it. Okay, great. Identify the following. You know what? These aren't words we've used. Well, anyway, I'm going to answer it anyway. Okay, just in case I do teach it before you get it. All right, a representative element, those are the ones that are filling the S's and P's. So representative elements would include columns 1 through 8 are representative elements. Transition elements are the ones here in the value that are filling their D's. And just so you know, the inner transition elements are the ones that are filling their F's. So iron is right here, and that makes it a transition element. Okay, it's a terrible transition. All right, sulfur is over here. It's in a numbered column. It's basically if you're in the S or the P blocks, you are known as a representative element. Represent blah blah blah. Okay, let's keep looking here. Number 19, uranium. Well, uranium is here, and these are known as the inner transition elements. So we'll just label that. I'll just say inner T's. How about that? An element with a partially filled F sublevel is also going to be, that looks like inert, is an inner transition. And let's see what we got here. 21, an element with a partially filled D sublevel, that's these here, and those are known as transition elements. Okay, I'm going to move this all up here. Alright, which element has the following electron configuration? So we look at number 22. We see we have 4s and 3d7. Well, let's see. Here's 4s, and here's the 3ds. 1, 2, 3, 4, 5, 6, 7. That, my friends, is cobalt. And then number 23, it's 7sF6. So let's move this up a little bit. 7s would be here, and then F6. 1, 2, 3, 4, 5, 6. That would be our old friend plutonium. And then finally, ooh, look at this one. It's busy. It's 6s2, 4f14, 5d10, and then 6p1. That would be thallium. So I'll put TH there. TL rather, sorry about that. Alright, let's see what we got next. Next we got, for each of the following elements, determine which ionization energy would be significantly higher than those preceding it. Well, what that means is, remember, valence electrons are easily removed and have low ionization energies, whereas elements on the inside are closer to nucleus and harder to pull from. So here's how we do this. Find arsenic, it's here. It's in column 5. That means it has 5 electrons that are relatively easily removed. So it would have 5 ionization energies that would be getting slightly higher with each of them. But when you got to the 6th one, since you could remove 1, 2, 3, 4, 5 electrons fairly easily, the 6th one, the 6th ionization energy, would be pretty difficult. We look at 26, sulfur. So I just look at sulfur. I go, well, sulfur has 6 valence electrons, so I would get 6 relatively easy to take electrons, so therefore the 7th ionization energy would be significantly larger. And aluminum has 3 valence electrons, so you could take 1, 2, 3 of those away. That 4th one would be significantly harder to take away. Well, let's see what we have with our next one here. Look at the ionization energies below to answer questions 28 through 30. Okay, how many valence electrons does each element have? Element A, let's see, it has 1, 2, 3 electrons that are fairly easy to take away, and then there's this ginormous jump right here. So therefore, I know it has 3 valence electrons. Let's try that again with B. I look at B. Where is the ginormous jump? It's right here. I have 2 fairly easy to remove and then a ginormous jump. So the 2 are easy because they're valence electrons. Now let's look at C. Where's the ginormous jump with C? Well, it's right here. Here's our ginormous jump. So I have 1, 2, 3, 4 valence electrons that are 4 ionization energies that are fairly low. The 5th one is hard because that was not a valence electron. There's 4 valence electrons. 1, 2, 3, 4. 29. Which of the following elements might have the ionization energies listed for element A? Well, element A, as we said before, has 1, 2, 3 valence electrons. So I need something from column 3, and that would be right there, boron. Let's see, where's my, that would be boron. Hey, we're almost done with our homework, look at this. And our last one is, which of the following elements might have the ionization energies listed for element C? Element C has 1, 2, 3, 4 valence electrons, and then the big jump. So I got to go to column 4, and therefore it would have to be something in this column here, and that looks to me like it might be our old friend silicon. Hey, I hope you enjoyed this homework as much as I did. Catch you next time.